Languages like English, Chinese, and Hindi are so specifically human that it seems hard to believe that many of us have gained new insights into the nature and evolution of language through thinking about discoveries made in the early 90s about the brains of monkeys. Giacomo Rizzolatti and his colleagues in Parma in Italy discovered mirror neurons in the macaque. These were neurons that fired both when the monkey executed a particular action and when the monkey was observing someone else do a similar action. How can we get from there to language? Well, two things are important. One is that when we try to compare the monkey brain to the human brain, we find lots and lots of differences, but we find that the area that corresponds to the part of the monkey brain that has the mirror neurons seems to be akin to the part of the human brain that is involved in language. Now, strangely enough, this area, called Broca's area, was traditionally thought of as an area for speech production. So why should we link an area that is involved with recognizing hand movements in the monkey with an area that is involved in recognizing and producing speech in the human? The idea is that when we study humans, we find that some of them use sign languages rather than spoken languages. And so the suggestion is that Broca's area is not really a speech area, but is in fact a language area. Okay, how do we get from monkeys, or at least our common ancestor with monkeys 25 million years ago, to us? Well, I take a whole book to spell that out. It's called How the Brain Got Language. But let me get across two main ideas. One is that what mirror neurons do is not recognize the richness of language. Rather, they recognize the actions of speaking or signing language. So if I make a vocal gesture or a manual gesture, you may recognize its form, but then it requires other parts of the brain to recognize what that means. So what I've done with a number of colleagues, starting with Giacomo Rizzolatti, was to suggest that the path to language involved changes in the brain that went from manual actions as doing practical things in the world to manual actions such as pantomime, which could convey things about our actions, and then on to proto-sign, to the basic sorts of gestures that could convey meaning, but doing so in a far more economical and conventionalized way than the way in which pantomime conveys meaning. And the suggestion is that one extra thing comes into play that's very important for human skill, and that's complex imitation, the ability to look at what somebody else is doing and break it down into pieces, and then master the different actions engaged, and then put them together again to come up with mastery of that skill. Lots of subtleties involved there. But the suggestion is that once a brain is available that can do all that, then over hundreds of thousands of years, such a brain can take us from the earliest humans, perhaps Neanderthals and Homo sapiens before they diverged from each other, to modern humans who can master language in the sense that they can master a phonology, in other words, the basic sounds, or the basic hand gestures with which they can put words together, and the grammar, which lets them put together meaning from individual words into new meanings, such as the meanings that I'm sharing with you today. And so it is this notion that the mirror neurons are at the core of recognizing the basic gestures and basic actions of language, working in concert with so many other areas of the brain that together can convey meaning and can link our behavior and our observations and our perception and our imagination to the sentences and other utterances of our language. And that is my story for today.